Good afternoon, everybody. Not only do computers read code, you also read code. A lot. Most of the time, actually. In fact, Uncle Bob says that the ratio of time spent reading versus writing is well over 10 to 1. We are constantly reading old code as the part of the effort to write new code. But a lot of the time, you look like that. You can't understand what I try to do. Programming is hard, inherently. But I make it harder by writing code that's hard for you to read. Luckily, this is treatable. Hi. Welcome to our clinic. I'm Moran. I've been a Fed at the editor group for the past 5 years, and I recently joined the Wix Academy as a training tech lead. Other than being a developer, I'm also a social psychologist. Well, obviously, I don't practice it for a living, but I do have a master's degree in social psychology.
And hi, I'm Jonathan. I'm not a psychologist. I'm a developer in the Wix code team, and obviously I'm not a psychologist, but my mother, she's a cognitive psychotherapist, and my wife is a clinical psychologist. So technically, that means I'm crazy.
We're here today to talk about how each and every one of you can use cognitive psychology to better understand how we read and interpret code. And as a result, take away a few techniques on how to write code that is more readable to others. So, what makes code readable? Readability is all about conveying intent and making that intent clear to others and to your future self. Have you ever looked at a piece of code and thought like, what? Only to discover a few moments later when you annotate that you were the one who wrote it a few years back? Yeah, me too.
Okay, so let's start our journey by discussing how to make your code, how to make your intent clear to others and to your future self. We'll start by playing a game. I'm going to show you a list of words on screen. And what we're all going to do together is we're going to shout the color of the word and not the word itself. Let's give it a try and see that we're all we all know what we're doing. So, let's do this all together. Green, purple, blue. Green, yellow, blue, purple, red, yellow, purple, yellow, red, blue. We got the point? Got the hang of it? Are we ready for the real thing? Are we ready for the real thing? Awesome. And all together. Purple, blue, red, blue, red, green, purple, yellow, blue, purple, green, red, yellow, blue, red, yellow, purple, blue, green, purple, yellow, blue, red, green, yellow, red, blue, purple, red, yellow, blue, green, red, purple, blue, green, red, yellow, blue, purple. I got lost in the end. Did you feel that? Did you feel the pain? This game is called the Stroop task. The Stroop task became a tool for American intelligence officials during the Cold War. A covert agent could claim not to speak Russian, but he'd take longer to answer correctly when looking at Russian words for color. And this is because we excel at reading and processing text. We're so good at this that we cannot turn this off. When we see text, we immediately, subconsciously, interpret it, process it, and it creates expectations in our mind. when the colors don't match those expectations, it hurts. The names we give our variables and functions in code, they too create expectations. They trigger a network of associations in our mind, putting images in our head, building those expectations. When the code doesn't match our expectations, it can hurt just as much. Good names are about creating those expectations and about fulfilling them. So, what would you expect isReadable to be? I'd expect it to be a Boolean, as everyone else here, and not a string value. Collection size, in this case, it's a number, and it has to be a number, and nothing else. Now, obviously, of course, none of us were going to write code like this. Of course not, of course. But maybe you've seen a function like this, where we call getShipmentDate. And I don't know about you, I'd expect to see a nicely formatted date string. But many times, I might encounter a Unix timestamp, and I'll say, oh yeah, that somehow makes sense. Or what about file names? Obviously, you expect to get a list of file names. But what about this? Do they include the relative paths or not? When we look at this data structure and we ask, does the word file names describe it correctly? I think most of us would say yes, that's what we have here. But when we look at this code, not as does the name match what I'm looking at, but ask ourselves, what will my reader expect? What will the next developer after me expect to see when he sees that name? Asking yourself that question makes it easier to understand that this name needs to be a bit different. We need a name which is unambiguous, which properly creates expectations. Every front-end developer here, and probably server developers as well, know the canonical HTML button example that we give it a click handler. We know this example so well that we no longer look at it. It's part of the plumbing, part of the syntax of the language. But we can help the readers after us understand, or to be exact, make our intent clearer by giving a proper name that will build expectations for the reader after us. Before I was in the Wix code company, I was in the team formerly known as Blog. And we had a production bug. The production bug was in one of our React components, specifically in the isReady method. Now, what would you expect an isReady method to do? Obviously, it returns a Boolean, and it was actually worked quite well. The bug that we had, the bug that we encountered, was in a HTTP post request sent from inside the isReady method. Eventually, we, of course, fixed the bug immediately. And I want to make this clear. This is good code. This code is in production and serves millions of users every day. My problem here is with the expectation. So one of the first things that we did as a team is rename this function to isReady with side effects. So the next developer that needs to read this code will know what to expect. This, of course, isn't limited to only development. It's in other aspects of R&D as well. Raise your hand if you've ever received an email saying, we're opening feature X to Wix users. Obviously. Now, for those of you who don't know, or if you're really new, you might think to yourself, oh, this is awesome, we're releasing a new feature to our users. Well, internally inside Wix, Wix users actually means Wix employees. And this, I want to make sure that everyone is clear on this. This has nothing to do with Wix. This happens everywhere. This happens in server libraries. This happens in front-end frameworks. I want to give an example. I want to give an example of a famous front-end framework that we probably all know, and some of us love, and I worked with it personally, by citing this question from Stack Overflow. The question goes, what are the differences between a service, a provider, and a factory in AngularJS? I myself found this question a few years back because those names didn't create the proper expectations, and I didn't remember, it was hard for me to wrap my head around it and know what did they mean. I want you to notice, to pay attention, that this question has over 3,000 upvotes, almost 2,000 stars. It was asked 5 years ago, and active 6 months ago. I took this screenshot 2 weeks ago to make this clear. And over 700,000 views. Hold that number in your head. Think about what Avishai said about 18.5 million developers in the world. This is 4% of the population of developers on planet Earth. If there's one thing I want you to take away from this section, is that when you finish writing a piece of code and you look at it, I want you to think about, not if the names match what you're looking at, but I want you to think, what is the next reader going to expect? And fulfill those expectations.
Let's play another game. Some of you might remember the famous Simon game from the 80s. And for those of you who don't, it's pretty simple. What you're going to do is to see the colors, remember them, and then shout them out loud. Don't worry, you'll get the hang of it. So, blue, blue, green, blue, green, blue, blue, green, blue, green, blue, green, blue, green, green, blue, green, blue, green, green, yellow, blue, green, blue, green, green, yellow, blue. You're good. Blue, green, blue, green, green, yellow, blue, green. Blue, green, blue, green, green, yellow, blue, green, blue. It gets harder, right? What I wanted to show you with this game is that our memory capacity is limited. But you were pretty good. There's only so many colors that we can remember. This is called in psychology our working memory or our short-term memory. You can think of it as our RAM, if you will. So our RAM capacity is limited. In fact, research has shown that most people can store in their working memory an average between 5 to 9 items on any given time. This has been introduced in psychology as the magical number 7 plus minus 2. So, what if we want to remember more? How can we hack the limits of our memory? Luckily, there is a way to do that, using chunking. Chunking basically means taking long pieces of information and splitting it into smaller, meaningful chunks or units. Let's see a little example of that. Say you had this sequence of colors in the Simon game from before. I want you to take a few moments and try to memorize them all. Raise your hand if you can recall the entire list without making any mistakes. Omer, obviously. Now, let's try it with chunking. Rugby, burger. Rugby, burger. Rugby burger. Rugby burger. Now, raise your hand if you can recall the entire list. Great. Let's see another example. Say you had this sequence of numbers, 51120139330. It's really hard to remember all of them at once. But by using chunking and splitting them into a date, a meaningful date, makes it so much easier to remember. Notice that this date doesn't have to have any particular meaning to you. Only by casting it into a date makes it easier to process. And for those of you, and I'm sure most of you don't remember, but I'm sure Avishai Avrahami remembers this date perfectly because this is the date of Wix's IPO. This is the day when Wix got public on Nasdaq. And let's see one last example of chunking. Say you had this array of 16 characters. It's really hard to remember all of them at once. By using chunking into words, now I only have to store an array of length 4 in my mental representation, and it's easier. So I bet you might think by now, okay, all of your examples are well engineered. What does it have to do with code in real life examples? I'm glad you asked. So say you had a function that makes a hotel reservation, and it gets all of these parameters. Obviously, all of them are mandatory. I can't do the function without it. But when I read it, it's like it stacks overflow me. It's hard to read and it's hard to understand what the function is really supposed to do with each of them. By using chunking and splitting them into meaningful arguments, objects, and namespaces makes it a lot easier to read and to remember as I read it. Let's see another example. Say you had this long function. Don't read it. Just say you had this long function. When I read it, it's really hard. By the time I get to the end of the function, I can't remember where I started. It feels like I have a stack overflow in my mind. If I use chunking and I split them into smaller, meaningful functions, now it's much easier to read it and to understand the story this function is telling me. It's much easier to get the higher level, the bigger picture, and to dive into the details as I see fit. It's also easier to debug, because if I know there's a specific bug in one of the lines, I only have to step into that specific line, and that's it. And one last example. Consider this function. What do you think it does? I bet if I give you a couple more minutes to go over it, you'll figure it out. But it's hard. It looks like minified code. It's really hard to remember as I read it what the last computation result was. If I use chunking into separate steps and I name my variables accordingly, first red, last green, first blue, last yellow, and then concatenate them all, then I understand, cool, this function is chunking by colors. To sum this section up, just think about what parts of your code can be meaningfully chunked into smaller, meaningful arguments, objects, namespaces, smaller functions, and steps.
So I want us to examine almost obvious fact that we all know about our awareness. How many people here, are you aware, how many people here are aware at this moment about the sensation of your clothes on your body? How many people here who is aware of the feeling of the chair pressing against you? How many people here are aware of the noise that the air conditioning is making, or the background sounds from the guys back there getting lunch ready? Somehow all of these, they magically disappear until someone brings our attention to them. This is due to our brain's amazing filtering power. All day long, we're bombarded with information, with light, movement, touch, smells, from all our senses. And this can be overwhelming. And that's exactly why our brains are masterpieces of processing and filtering out information. But it can do so only if your mind can predict the noise. If it can predict the noise, it can easily filter out what's not important. Daniel Kahneman, for those who have heard of him before, a Nobel Prize winner, researcher in the field of human decision-making. He describes two complementary systems of thinking that we all have. System 1, wonderful name, completely generic. System 1 is fast, it's intuitive, it's emotional. System 2, on the other hand, is slower, it's deliberate, and it is logical. System 1 is the one that does the filtering. I want you to think back about some time where you drove a car. You went from one destination to the other, arrived at your destination, got out of the car and said, how did I get here? What was along the way? Has that ever happened to you? Yeah, I see all these nods around. This is called, it has a name, a cute name even. It's called the highway hypnosis. This is when System 1 takes this mundane task of driving your car so that System 2 can focus on what's really important, like what's the podcast that you're listening to, or this project at work, or what you want to have for dinner. When System 1 doesn't know what to do, it says, I don't know if this is important or not. Let's ask System 2. Let's interrupt it. Have you ever felt that before? I'm sure you have. For example, if you've ever read a piece of code and asked yourself, wait, why are there single quotes versus double quotes? Why are there sometimes semicolons or no semicolons? Line breaks, or what exactly is going on? And you found yourself spending time on nonsense. That's System 1 saying, hey, I don't know what to do here. Let's ask System 2. And suddenly, you're messing around with code styles. Having a consistent code style convention allows System 1 to filter out all the syntax and all the plumbing that has to do with the code, allowing System 2 to focus on what's important, on the business logic, on the intent of the writer. For those of you who aren't front-end developers, or front-end developers, anyone that has ever written JavaScript, how many people here use Prettier? Woo! For those of you who haven't or have never heard of it, use Prettier. You'd be surprised in a week or 2 or 3 what a production boost it's going to give you. But, of course, linters, they can't solve everything. There are problems which are inherently difficult. For example, obviously, naming. When I show you this code, it takes a moment. You look at it, you need to read the name, you need to read the functions in order to start to understand what's going on, and okay, quickly understand that this is an API for fetching data. If you have similar actions, if you have similar domain entities that do similar things, give it a single name. Give it one name, choose one word, and use it consistently. That allows System 1 to quickly recognize it and filter it out, allowing System 2 to focus on what's different between those functions, on what's the story that we're trying to tell. Itai Stekel, I love this quote, he used to be in the editor infrastructure team. And they were performing a refactoring, and he at some point decided to post one of their findings in the editor Slack channel. And it goes like this. He asked, how do you get the layout details for the preview frame? So, if you'd like, you can invoke rendered editor API, get preview size. But some might say, no, I want the editor namespace, so I am going to invoke get preview position. But some of you might prefer the previous naming of the function, which was better. So you could also go to editor, get preview position. Unless you're working from the UI stage and you want to use that namespace for some reason. Or maybe you don't want to invoke a function, so you want to pull it out of the config. Or maybe from the state. Or if you don't like the whole rendered thing, you can just go to the core module and pull it out from there. If you have more than one way of getting a piece of data, more than one function that you can invoke to do the exact same thing, that is System 1 saying, I'm not sure what I should do here. Let's ask System 2. If you have only one way of getting that data, only one way of performing that action, then System 1 just knows to pull out immediately which function you need to call, allowing System 2 to focus on the story you're trying to tell, on the business logic you're trying to implement. System 1, it's a superpower. When you hear a loud noise, it immediately locates the noise. It immediately locates the source. Boom, you turn your head. You just know it's there. You don't think about it. System 1 can complete well-known phrases. My name is Inigo Montoya. You killed my father. System 1 can read text off billboards so you make the right turn. Of course, it can drive your car on empty, boring roads. And it can do so much more. And that's why you should take advantage of this. It can do all this only as long as you are predictable. And that's why I say, let System 1 do its job. Write predictable code. Make filtering easy again. But some of you might think of situations where we want this interruption. Imagine a child jumps into the middle of the road, and you want to immediately become aware of this. You want to stop the car. You don't want to continue on with ignoring it and thinking about the podcast. This mechanism where System 1 interrupts System 2 can sometimes come in handy. It can be useful. We can use it to put up warning signs. You can prefix a function with the word deprecated in order to say, hey, 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 don't use me, I'm deprecated. There's probably a different way. Ask another developer if you don't know. We can use it to say, hey, I can already see the smiles coming up from people that recognize this function, which is a very good function, but it comes and says, hey, functions usually do only one thing. I do two. There are two things I do. It's not good, it's not bad, it's a fact. Be aware of this, don't be surprised. Or the example I gave you previously with isReady with side effects to say, if you're coming in here, I'm putting up a warning sign. Notice, this might not do exactly what you think it does. Now it does. So, if there's one thing I want you to take away from this section that we talked about, is I want you to let System 1 do its job. I want you to write predictable code and to make filtering easy again. Let's recap for a moment. We talked about what expectations we build, what expectations we create for our users and fulfilling those expectations. And we talked about taking our code and chunking it into meaningful units to help tell a story. And we talked about make filtering easy so that System 2 can focus on what's important. But there's one inherent problem with these three tips that we're giving you, or techniques that we're talking about. And the problem is that these are all subjective. Each and every one of them. You cannot know if you're doing the right thing. And this leads us to our final section, where we want to talk about the only way, well, not the only way, but you need to validate that your code is readable. You need to validate that you are doing all these things. And if there's one takeaway I want you to take away from this talk, is code reviews. You need a code review. Right? Code reviews. Code reviews? Code reviews. Code reviews? Code reviews. You need a code review. There is one way, one easy way, which is a convention, it is a standard in our industry to validate that your code is readable, that your intent is clear. And that is a code review.
Now for another game. Raise your hand when you spot the man's face. For those of you who didn't see it, it's right here. Now that you've seen it, you can't unsee it. It's hard to understand how you couldn't see it in the first place. It just pops out. It's the same thing with your code. Since you already know your intent, it's clear to you. You were the one who wrote it. But the thing is that others only see a bunch of coffee beans. The only way to verify that your intent is clear is with a code review. When you tell me where to focus and what to look at, that is all I see. When you ask me for a code review and then explain to me your code, it's like you're telling me to count passes. I won't be able to see the gorillas in your code. I won't be able to see the bugs. I won't be able to see the design flaws. And you won't know if your code is readable or not. That's why code reviews should always be cold. And by cold, I mean, don't give me an intro, don't tell me what you did or explain your design, just send out a pull request and the reviewer will look on its own, sorry. That's why code review is a dish best served cold. On a more personal note, I would like to tell you that I used to hide the fact that I also studied psychology in addition to computer science. An interviewer once laughed at me about it and claimed I was wasting his time because of it. It was in one of the first interviews I had when I first finished school. I always thought a developer should be this cold, autistic fella, and if I'm the kind of person who understands how people think, react, analyze, and behave, then I should just keep it to myself. But now I know that knowing these patterns and actually using them in predicting makes me a better coder, a better reviewer, and a much better engineer. And that's because any fool can write code that a computer can understand. Good programmers write code that human can understand. Thank you.
מדהים.